What's going on, everyone? Johnny Bannon here at Trepa Technologies, and in this video we're going to go over the differences between software-defined networking, traditional networking, and also our APIs, southbound and northbound APIs. We'll save REST APIs for later. So if you're watching these videos in order, thank you for viewing, and this is part of our free full CCNA course on YouTube. If you're interested in our bonus content, our labs, access to our team of networking and IT professionals, our learning management system, which has flashcards and over 1,200 practice questions, click that link in the description below and see how you can enroll in our self-paced and live virtual CCNA training. Now, with that being said, let's go ahead and jump right into the lecture. Okay, so where we left off, if you're watching these videos in order, we just got done talking about the control planes, and now we're talking about software-defined networking versus traditional networking. So, I want to start with traditional networking because that's what we've been learning this whole time, and it's kind of easier to know the differences once we define this at a high level. This whole course, this is what we've been playing with, the traditional network. We've been getting into the CLI of routers and switches and configuring them, traditional networking. So here's some key things about them. So we call this a distributed control or distributed infrastructure. So in traditional networking, control plane functions such as routing decisions and network policies are distributed across individual network devices. So individual devices, like if this is R1 here, we have the control plane and the data plane all in one device. So each device makes autonomous decisions based on its local knowledge, what it knows locally about its neighbors and what it knows from its neighbors. Then we have static configuration. So network configuration is typically static and device specific. So when we do changes and updates, it often requires manual configuration of individual devices. This can be time consuming and also error prone because of our human error, especially in those larger complex networks. In traditional networking, there is no or limited programmability. So traditional network devices have limited programmability and lack standard open interfaces for external applications. So what we mean by this is the old Catalyst switches, we're talking maybe like 2000, 3000 series, they may not have APIs available as part of the operating system, as part of the code base, to allow external controller to control it. So they don't have programmability. Now they can most likely be automated with Python or Ansible, but we're talking software-defined networking here. So complexity. So managing and troubleshooting networks can be complex, as network administrators need to configure and maintain each device separately. So again, we don't get that single pane of glass. We do not get that ability to send policy changes or provision or manage devices with a click of a button. We have to go individually into maybe 200, 300, 400 different switches to make like a security compliance change. And then typically, now this is kind of getting away from Cisco because in CCNA we should always use Cisco devices. But traditional networking is vendor specific. So you're going to rely on the vendor to always come up with patching and solutions for you. With software-defined networking, the original point was with the OpenFlow project was for any vendor to become part of that controller-based networking. Now, of course, this is, capitalism in the market. Cisco, their DNA centers, their SD-WAN, it's for their Cisco devices, but it's still software-defined networking. So that's traditional networking. Key points here is, again, this distributed control. That's something you have to know, something that my students have talked about, saying that this is important to understand. Now with software-defined networking. So the whole point of software-defined networking is to centralize the network control plane. So to take that network control plane, de-distribute it and put it into a single pane of glass. A centralized controller that manages network-wide policies and makes decisions based on the global network view. This allows us to have automation and orchestration. So SDN facilitates the automation and orchestration of simple network tasks. It could also do some corrective action. SDN is dynamic and programmable. So with the SDN fabric underlay, and that's our actual physical devices, they're going to have those APIs available to be controlled by an external app or program. And then you also have simplified management. Because we're going to be under one single pane of glass, we're going to have that central point of control. It abstracts that network complexity and it makes it easier to manage. SDN also often includes network virtualization capabilities, so allowing the creation of virtual networks that can be independently managed and customized. So here we're talking like in the data center, right? Maybe getting into VXLAN, but also just talking about maybe Cisco CSR solutions. And this is beyond the CCNA. I just want to get too deep into that. But SDN on the last note provides adaptability and scalability. Okay, so here, what do you guys think? Pause the video. Is this software-defined networking or traditional networking? This is going to be traditional networking. And why? Because here, imagine we opened up Secure CRT, my choice of terminal emulator, and then we got a CTO or a compliance. Say, hey, we need to change our enable passwords on all of our devices. So, okay, well, I'm in the east region of my large enterprise. We only got 4 spoke offices with single routers, so I got 4 routers to configure. Maybe it's late at night, the security compliance came in. For whatever reason, maybe we got exposed. Our running configs got exposed. So now I open up Secure CRT. I got all those multiple tabs. I'm rocking and rolling. I SSH to all 4 of my routers, and I start doing some configuration. So I do router 1 first. Boom. Done. I write that bad boy to memory, and we're good to go. Boom. I do router 2. Good to go. I'm about to put this on my KPIs. My performance has been amazing. I did some tickets in the NOC today. And then, boom, we come to router 3. It's late in the day. I knock this out. I finished router 4. I send an email or I go to our change management process. Maybe I use Jira ticketing. Maybe I use ServiceNow and I say ticket complete. Now the whole infrastructure, our whole enterprise, the NOC says, hey, that junior network admin killed it today. He or she knocked this task out of the park. 2 weeks later, we get a report on R3 on one of our dashboards. Maybe we have like a SolarWinds management, right? That says, hey, in R3, go check it out. There's some high CPU usage. So we go to SSH in. We don't get access. Well, why? Well, let's go look at our change management. What changed? Hey, you, junior network admin. Did you put in this new enabled password? You say, yes, let me try. Boom, you get denied. Well, what's happening, guys? Because I'm a human, I made an error here. Look at this. And I probably didn't write these out in like VS Code or at least Notepad to see the configurations I did. And maybe we don't have an ICE server that's doing accounting. So who knows what the password could be? And now we got to get someone on site to go console in. It's a big mess. This is traditional networking. This is why software-defined networking, it is taking over. You know, medium-sized businesses use Meraki. Everyone's using DNA Center. There's not always one size fits all. Maybe it's split. Maybe some traditional, some DNA Center. But that is the problem with traditional networking right there. So let's go ahead and talk about software-defined networking. So in software-defined networking, we have our controller here in the middle. And this abstracts all the human error from your CLI commands. And how does it do that? Well, in this software-defined networking diagram I have here, here's our dashboard, our DNA Center dashboard, and here's our DNA Center appliance. This is the controller. Now, where have you might have seen this in your studies if you're watching this? With our wireless LAN controllers. They're that centralized controller that also abstracts the profiles and the configuration from the access points. You do it all from the wireless LAN GUI. Well, same thing here. Now with our routers, if we want to make a change, like a new routing policy, a new OSPF route, whatever the case may be, guess what? The control plane is now centralized here. And we have that single pane of glass for us to monitor, troubleshoot, and manage our networks. Now, what do you see here, though? There's the data plane. The data plane is still there. So how does this controller push configuration? How does it push policy here? Well, it's going to use something called SBIs. Guess what those are? Southbound interfaces, or API, using maybe like netcomp to push a configuration change to that router. And in that netcomp, maybe we're doing data serialization with like JSON or XML, to make it more human readable to push those changes. And we're going to get into that, okay? Now, what if for troubleshooting? What if we want to be able to see an interface's IP address here? Well, the same thing. We could do a request down here to see an interface, and that can push it back up, and then that can go back up here, okay? And now we can see interface information, all from our DNA center. So this is software-defined networking. Now, before we get any further, let's go over what an API is. So an API stands for Application Programming Interface. It is a set of rules and protocols that allows one software application to interact with or request services from another application, system, or service. Typical API you'll see is an HTTP request, right? A get, post, put, delete, getting information from a database when you go on someone's website. It happens every single day when you're on the internet and you don't know about it. So APIs define how different software components should communicate. So even here, between our database and maybe our front end of our website, we have APIs. So what's the role of an API in networking? So in the context of networking and software-defined networking, APIs play a crucial role in enabling network engineers to automate tasks, retrieve information in a structured format, we'll get into that with JSON and XML, and control network devices and services programmatically. They serve as the language that software applications devices use to communicate to each other. And in SDN, or software-defined networking, we have southbound and northbound interfaces. So what are the different types of APIs in networking? So we have REST APIs, which we're going to get into. So we have REST APIs, which stand for representational state transfer API. So this uses a standard HTTP methods such as get, post, put, and delete to interact with resources on network devices or SDN controllers. So REST APIs are widely used for simplicity, flexibility, and compatibility with the web. So engineers, and you go on our Academy site, it's all REST APIs, right? So engineers can use to interact with the database on the front end. So REST APIs are used to perform tasks like configuring devices, retrieving network data, and managing network services. And then, of course, we have our northbound and southbound APIs, which we're going to get into in our next slide. And then to leave it with just a key note here, APIs facilitate data exchange between programs. And when we're looking at our infrastructure from a software-defined networking point of view, that router, that switch is a part of the program. That's part of the fabric underlay that we're interacting with, okay? So the southbound interface or API. So a southbound interface in networking refers to the communication link or interface through which instructions and commands flow from the network controller or management plane, which can be both, down to the network devices in the data plane. So what do we see here? So we go back to these interfaces, right? Back to this diagram. We see that when we're pushing this routing table policy or we're making a change, it's with our southbound APIs, which again can be like netconf or restconf. So that's what the southbound API is. So functionally, southbound APIs allow the network controller, which is typically part of the SDN solution or management system, to send specific instructions and configurations to the network devices. They also send configurations and policies. So these instructions can include network configurations, policies, routes, ACLs, quality of service settings. They also allow you to program network devices. So essentially, southbound interfaces are the means by which network admins and SDN controllers program and configure the behavior of the network and our fabric underlay here of our actual infrastructure. Okay, so now what else do they do? So they have protocols and standards. So southbound interfaces often rely on standard protocols like OpenFlow, netconf, and restconf, like I've been talking about, to ensure consistent interoperable communication between the planes. So what we're trying to say here is that these languages need to talk between our southbound infrastructure and interfaces and our control plane. In Cisco, netconf and restconf are what we're going to be using. SDN and automation. So southbound interface are the foundational element of software-defined networking. They enable the centralization of network control and automation by allowing an SDN controller to communicate with network switches, routers, and other devices. So examples of this as far as Cisco products go. So we have, of course, Cisco DNA Center, Cisco ACI, which is application-centric infrastructure, and then one that's not on there is SD-WAN, which also isn't a part of the CCNA exam, which is very sad because I just did a huge SD-WAN lab like a couple months ago. It was awesome, and I'm eventually going to put out a video series for it. But besides that, these solutions, they use southbound interfaces the same way that any of the open source ones would, like, OpenFlow here. They enforce security rules and ensure the desired behavior of the network infrastructure. So to cap off, right, what a southbound interface is, it's a vital component of modern network management and SDN. It serves as a conduit through which network controllers, management systems, and SDN solutions communicate instructions and configurations to network devices in the data plane. So again, these southbound APIs allow us to tell the data plane how to send packets. So essentially, nothing's changed, right? We're still using this control plane traffic, which is now these southbound interfaces, APIs, netconf, restconf, and policy configuration, down to this fabric underlay to that router. And when that packet comes in, guess what? At the end of the day, that router's still doing his or her job, switching that packet and routing it from gig 00 out to gig 01, being informed from its control plane, which is now centralized. So that is a southbound API. Now, to get into northbound interfaces and APIs. So in the world of networking, a northbound interface refers to the communication link or interface through which information, data, and requests flow from network application services or external systems toward the network controller and management plane. Whew. So let's break that down, right? So with the northbound interfaces, now we're getting into more API programmability. And what do I mean by that? So I'm on my dashboard here, and I click the little hamburger icon, and I say, hey, I want to look at configuration on R1. So I send that GET message down. This sends the SBI API down. It returns it. It sends it back into the structured data format, JSON or XML, and then gets put into that GUI for me to look at. And now I have that information about R1. I did that using a northbound API, asking this controller, which is going to send it south down to that fabric underlay. So it has that application interaction. So northbound interfaces enable communications between application, services, and external systems. So even beyond this DNA center, maybe I just code up a REST API to just get information from DNA center on my local computer. That's also a northbound API technically. And that flow goes like this. Hey, DNA center, send back to me this information. I want it locally for whatever reason, right? And then it goes and gets that information and comes all the way back up, okay? So what else does it do? Requests and queries. So these interfaces allow applications to send requests for network configurations, status updates, or information about the network state. The abstraction layer. So northbound interfaces often provide an abstraction layer that simplifies interaction between applications and the underlying network infrastructure. So again, we also have protocols and standards here. The one you're going to see all the time is RESTful APIs, meaning using HTTP, using the GET, the POST, the PUT methods, and delete methods, and create and CRUD. We're going to get into all this. It also plays the crucial role in SDN and orchestration. So they expose network services and capabilities to high-level applications and orchestration systems. So again, some examples: DNA Center, SD-WAN, and application-centric infrastructure all use northbound APIs. Okay, so that's going to top it off for the slides. Now let's bring up a whiteboard. I want to go over something. Let's actually compare just regular automation. And let me bring pen. Regular automation versus SDN. Now, what do I mean by that? So SDN, that's going to be actual, in Cisco's eyes, that's going to be actual vendor technologies and services like DNA Center. So when we get into DNA Center and we onboard a device to DNA Center, it now allows us that single pane of glass to configure the fabric underlay. That fabric underlay or the underlay network is going to be actual hardware. Our routers, our switches. So what's the end goal of SDN? To simplify management and to get rid of human error. That's the goal. To simplify, to centralize, and to pretty much give us less burden as network engineers to focus on more important things like architecture and engineering besides menial tasks like VLAN creation, okay? We can do that with a centralized GUI. So simplify, centralize, okay? And perform things from a centralized manner. Now, automation. This is going to be different from SDN. The end goal is the same. The end goal of automation is still to simplify, have consistency, I can add that, and consistency amongst the network. But here we use things like Ansible, like Python, to actually script. And this is not vendor specific. Python, the NetMiko library, has a bunch of different functions and modules for not just Cisco, Juniper, Huawei, any of the network infrastructure, Dell, right? HP. Ansible, same thing. Now, with regular old network automation, you can be a bit more specific in what you want to do. Whereas SDN controllers, if it's not part of that SDN system, like DNA Center doesn't allow you to do something specific that you want to do, then you could write a script to do that. And with automation, we still look at the fabric underlay, our actual hardware devices, as a part of our entire infrastructure. And we attempt to do something called IAC, which is infrastructure as code. So instead of looking at our devices like a traditional network with automation, we try to look at them as part of the entire program, as just pieces of a code and programmability for our infrastructure, okay? So that's kind of just high-level differences. Now, before we get off of this slide here, because I'm not going to do a video just on DNA Center. I don't think that's going to be part of the exam. So what I want to show you here is this DevNet. So Cisco DevNet solution. Here we have this DevNet sandbox, and we're about to look at a DNA Center's like dashboard. So here, Cisco provides this for free. You don't have to reserve it. It's just go on this website, sign up, and now we're going to be able to look at an actual DNA Center dashboard. So I'm going to go to this address right here. I'm going to type in these credentials, DevNet user, and then Cisco 123 bang or exclamation point. So it's going to be DevNet user, then Cisco 123 exclamation point. And now check this out. It's going to say welcome DevNet user. We can actually click here. We can hit explore. And once this loads up, we can now look at this single pane of glass. So for some of you that may be watching this that have done traditional networking or you're trying to get into networking, you're going to be like, wow, this is crazy. Don't worry. As a CCNA, I don't believe you're going to be applying for jobs expecting to be an expert at this. But just to click around, this is just a web-based GUI. We can create policy. We can create QoS policy here, right? Now, we're not going to get the full functionality of this, like if we were to do it like in our home lab, which again is very hard. We can provision. We can look at the fabric side, so the fabric underlay, right? Now, again, we're just going through this. We can look at different services like site-to-site VPNs, and you can start playing around with Cisco DNA Center and actually start labbing it up on your own completely for free. And Cisco has a YouTube channel that you can subscribe to that has training for this that says, hey, go to our DevNet box and we'll show you how to get some training on Cisco DNA Center. We can run our first report, and it's awesome. And look at all the things that we can look at. So it's pretty cool. So this is what software-defined networking is. Now, let's go to ChatGPT. I'm going to show you what automation would look like. I could just show you my GitLab as well, but just for the sake of the video. Let's say we wanted a script that automated creating VLANs on a Cisco switch and a Juniper switch. Let's see if ChatGPT can do this. So can you write me a script using Python to create VLANs on a Cisco switch and a Juniper switch? And look at this. It's going to show us how to do it for Juniper and for Cisco switch. It actually makes a function here, or a module, but that's pretty cool. So now, from maybe like a centralized server running in our environment, we could have this Python script. We can make it executable. Maybe we even make our own custom website that allows us to push these scripts. With Ansible, we have things like Ansible Tower. So I'm going to say, can you do the same thing, but for Ansible? And we can create playbooks and then upload them to Ansible Tower. And that's a web-based GUI or dashboard that allows us to run playbooks with a click of a button to automate our network. So just to show you two examples of how we can automate and how we can look at SDN. Now, in future videos, I'm going to be going over like Python automation and Ansible automation, just in quick little bonus content videos that will be available on our actual self-paced paid course. So if you click that link in the description below, if you buy that course, coming in like January or February 2024 will be that bonus content. All right. So I want to thank everybody for viewing. We appreciate you tuning in. I know these videos were kind of long, but we want to thank you. Please feel free to like and subscribe and to share this content with your friends. And if you're an active duty soldier, you can get our training for free. So you can use something called Army Igniter, the Army Cool program, to get the Army to pay for all your credentialing and certification assistance. So if you're interested in that, click that link in the description below, and we look forward to seeing you.